last class, we have discussed various things like differential equation, the definition of a differential equation, order, degree of a differential equation, ordinary and partial differential equations, and the formation of a differential equation, the solution of a differential equation, general and particular solution, etc. Therefore, I request you, before watching this video, please make sure that you have watched the first part of the differential equation. So let us start the exercise 8a. Exercise 8a. So the first problem is find the order of the differential equation obtained by eliminating the arbitrary constants. We can say parameters as well. Arbitrary constants b comma c from the equation xy is equals to c e power x plus b e power minus x plus x square. Solution: given equation is xy is equals to c e power x plus b e power minus x plus x square. So this is the given equation. So to say about the order of a differential equation, since this equation contains two arbitrary constants c and b, therefore we need to differentiate it twice for the elimination of c and b. So then first time if you differentiate, we will get dy by dx. Differentiating y with respect to x is dy by dx. This dy by dx, if we differentiate again, then we will be getting the second order derivative, which is d square y by dx square. So let us do that. So differentiating with respect to, directly without actually differentiating, we will arrive to a conclusion that order is 2 because it contains two arbitrary constants. It is clearly given in the question itself. So here order is anyway 2, and if you want to know the differential equation, then we have to eliminate as well. So differentiating with respect to x once on both sides, then we'll get xy, this is uv, x into d by dx of y is dy by dx plus y into d by dx of x is 1. Last year we have studied u v dash plus v u dash. U means x here, v dash means d by dx of y is dy by dx plus v, this is y here, into d by dx of x is 1 is equals to, now c into d by dx of e power x itself plus b into d by dx of e power minus x. Let us suppose this to be x. E power x derivative means itself. So e power minus x into d by dx of minus x minus 1 plus x square derivative is 2x. So this is equals to c e power x minus b e power minus x plus 2x. This is x dy by dx plus y equals to, again differentiating with respect to x on both sides, then this is x into d by dx of y. This is first order derivative. If you differentiate it again, dy by dx derivative is d square y by dx square plus u v dash is over plus v u dash dy by dx into d by dx of x is 1 plus d by dx of y is dy by dx is equals to c e power x derivative is itself minus b into d by dx of e power minus x is minus e power minus x. Minus of minus is plus e power minus x. Therefore, x d square y by dx square plus this is dy by dx, 2 dy by dx. Next, here this is not eliminated at, but we can eliminate it through the suitable substitution. So here xy minus x square is equals to c e power x plus b e power minus x. So if you substitute c e power x plus b e power minus x with this variables xy and minus x square, so this is the required differential equation. So this is the required differential equation, and if you see the answer in the differential equation, it is free from the constants c and b. These are the arbitrary constants or parameters which we have eliminated. Therefore, this is the differential equation, and if you focus the answer here, dy by dx is the first order derivative, d square by dx square is the second order derivative. So the order is defined to be the order of the order is defined to be the order of the highest order derivative occurring in the differential equation. Therefore, this is the first order and this is the second order. Therefore, order is equals to the highest order derivative is 2 here. So order equals to 2. Find the order of the differential equation of the family of all circles with their centers at the origin. So that means we need to find the differential equation of the circle which are having the center at the origin. So there is not only a single circle following that condition. There are infinitely many circles. For example, this is the coordinate axis and this is the circle having center at the origin. Having center at the origin 0, 0. So what is the equation of the circle having center at the origin and radius r? X square plus y square equals to r square, which is the standard equation of the circle. But there may be so many circles having center at the origin and having the different radii. So all these circles, we can say the concentric circles, etc. So, for example, this is 1 unit, 2, 3. That means this is the radius 1 unit having center at the origin. This circle has got the radius 2 and the center at the origin, and this circle has got the radius 3 and center at the origin, and there may be infinitely many. So solution, so the family of all circles having center at the origin are x square plus y square equals to r square, where r is the radius. That means this is the parameter or arbitrary constant. So therefore, since we have only one arbitrary constant for which we need to differentiate how many times? One time only. Since r is the only arbitrary constant we have, therefore without actually doing the process, we can say radius, we can say order is equals to 1 directly. So, and degree is order's power, which is degree is also 1. So without actually doing it, otherwise we can even solve. So if we try to solve this, then this r would be eliminated, and whatever the equation that we are going to get ultimately is nothing but the differential equation which we are looking for. So, but here the differential equation is not asked, yet we can find. So differentiating with respect to x on both sides. So this is equals to d by dx of x square is 2x. So y square derivative we don't know, but y if you take x, d by dx of x square is 2x, that is 2y. Since y is treated to be x, we need to differentiate it y with respect to x, dy by dx is equals to r square. Since it's a constant, its derivative is 0. So 2 can be taken common, x plus y dy by dx is equals to 0. Therefore, x plus y dy by dx is equals to 0 is the differential equation. Therefore, what is the order? Here, dy by dx is the first order derivative by differentiating y with respect to x once. So, order is equals to 1. So, this is the order. Since this being the unique derivative, which is the first order derivative, and degree is the exponent or the power of this order, which is degree is equals to 1. Form the differential equations of the following family of curves where parameters are given in brackets. So here C is given. That means C being the only parameter for which we need to differentiate it once. In the process of differentiation, if that parameter is not eliminated, but with the suitable operations we need to eliminate it. So let us do that. So differentiating with respect to x on both sides. So y d by dx of y is dy by dx is equals to c constant separated from the process of differentiation. So into, so this is the variable. X square derivative is 2x, but x minus c derivative we don't know. Let us suppose this to be x. X square derivative is 2x. 2 into x minus c into so d by dx of x minus c 1. Since this is x, now it has become x square. X square derivative is 2x. So into, since we have treated it to be x, into d by dx of x minus c. D by dx of x is 1 minus d by dx of a constant 0. 1 minus 0 is 1 into this. Now I'll divide this by this. Dividing let us suppose that this is 1 and this is 2. Dividing 1 by 2 implies y by dy by dx is equals to c into x minus c whole square by c into 2c into x minus c. Because we need to differentiate it once, but after differentiation also the c is not eliminated. So we should not differentiate further, because since it contains only one arbitrary constant for which we need to differentiate it once only. In the process of differentiation, if it is not eliminated, then with the suitable operations, here this operation is division I have taken. So here CC gets cancelled and this x minus c once it's cancelled. So therefore 2y by dy by dx is equals to x minus c. 2y by dy by dx is equals to x minus c. Therefore, if you want c is equals to x minus 2y by dy by dx. Now, Now substituting c comma x minus c in 1, that implies y is equals to, what is c? X minus 2y by dy by dx into x minus c is, this is the x minus c. What is the x minus c here? From this, x minus c is equals to 2y by, so this is x minus c, right? 2y by dy by dx. So the same if I substitute here, 2y by dy by dx. This is equals to y is equals to x dy by dx minus 2y into 2y whole square is 4y square by, this is dy by dx, this is dy by dx whole square, dy by dx whole cube. This implies y into dy by dx whole cube is equals to, this is 4y square into x dy by dx, x dy by dx minus 2y. This y and this y gets cancelled. This implies dy by dx whole cube is equals to, this is 4xy dy by dx, 4xy dy by dx minus 2 4s are 8, y into y square, 8y square is the required differential equation. xy is equals to a e power x plus b e power minus x. There are two parameters now. Earlier one is one parameter, that is c, for which we had differentiated one time. Here we require twice differentiation. So differentiating with respect to x, we get with respect to differentiating y with respect to x one times. So x into, this is uv, x into dy by dx of y plus y into dy by dx of x, so to say, is equals to a into x itself plus b into dy by dx of e power minus x. Let us suppose this minus x to be x only. Dy by dx of e power x is e power x. So e power minus x into dy by dx of minus x is minus 1. This is x dy by dx plus y dy by dx of x is 1 is equals to a e power x plus into minus minus b e power minus x. Again differentiating with respect to x, we get, implies x into dy by dx of dy by dx. Again this is uv plus y dy by dx into dy by dx of x. So uv dash plus vu dash plus y with respect to x, dy by dx of y is equals to a into dy by dx of e power x minus b into dy by dx of e power minus x minus e power minus x. Minus of minus is plus. But a, b or not gets eliminated. But what is a e power x plus b e power minus x? xy. So can we replace this to be xy? Now This is x d by dx of dy by dx. First order derivative is second order derivative, d square y by dx square plus dy by dx of x is 1. So this is dy by dx plus dy by dx of y is dy by dx. dy by dx, this is dy by dx into 1 is dy by dx plus dy by dx. 2 dy by dx. This is a e power x plus b e power minus x. If you transpose this, minus xy equals to 0. This is the required differential equation. So this is the required differential equation. The next problem is third one. Y is equals to a plus bx into e power kx. Here a comma b are given. You may ask a question, sir, k is also a constant, but it's not a parameter or arbitrary constant. He just mentioned a comma b only. Therefore, in the answer, we will get a k also. So, the answer will be free from the arbitrary constant a comma b, which is mentioned in the question itself. In the brackets, a comma b is given. Therefore, differentiating with respect to x once. So this is dy by dx is equals to, this is a plus bx uv, a plus bx into e power kx derivative is e power kx into k u v dash plus vu dash e power kx into a plus bx derivative is a b. A derivative is 0 constant, bx derivative b into d by dx of x, b into 1. So this is equals to a plus bx into e power kx into k plus b e power kx. Now this is equals to k into, this is k into, this is a plus bx into e power kx. This can be written as y. This is a plus bx into e power kx, which can be replaced by y plus b e power kx. This is dy by dx. So after differentiating once, we got this. Again differentiating, we get. So dy by dx, this is first order derivative. Differentiate this first order derivative with respect to again second order derivative, d square y by dx square we will get that. D square y by dx square is equals to k into d by dx of y, k into dy by dx plus b into b constant, e power kx derivative is e power kx into k, e power kx into k. So we can see k is common in both of them. K is common in both of them. So dy by dx. So otherwise we can write this to be k dy by dx, but the another constant b is not eliminated at, but this can be written as k into dy by dx of k into dy by dx plus b into e power kx. So k into dy by dx plus, from there b into e power kx can be written as b into e power kx. From this, b into e power kx is equals to dy by dx minus ky. So I will substitute here. So b e power kx can be replaced as dy by dx minus ky. So therefore answer is d square y by dx square. This is dy by dx, dy by dx, 2 dy by dx into k. So minus 2k dy by dx. This is k into k square minus k square y. If you bring here plus k square y equals to 0 is the required differential equation. Y is equals to a cos nx plus b. A and b are the parameters given. Differentiating with respect to here, needless to say, there are two arbitrary constants for which we need to differentiate it twice. Differentiating with respect to x on both sides once. Then y with respect to x is dy by dx is equals to a into, so let us suppose this whole to be x, cos x it has become now. What is the derivative of cos x? Minus sine. So minus sine nx plus b into, since this we have taken it to be x, later we need to differentiate it. D by dx of nx plus b. So d by dx of nx plus d by dx of b. D by dx of nx is n into d by dx of x is 1. N into 1 n plus b derivative is 0. So this is n. Again differentiating with respect to x on both sides. So dy by dx derivative is first order's derivative is second order, d square y by dx square is equals to minus na is a pure constant, a n or constant. Now sin nx plus b, treat nx plus b to be x. Sin x derivative is cos x. Cos nx plus b into, since this we have treated it to be x for the time being, we have to differentiate it later. Into d by dx of x plus b is into n. Now this is equals to minus n into n square into a cos nx plus b. Now if you see, this whole is y, therefore minus n square y, therefore d square y by dx square plus n square y is equals to 0 is the required differential equation. Obtain the differential equation which corresponds to each of the following family of curves. The rectangular hyperbolas which have the coordinate axis as asymptotes. The difference between this problem with the earlier one is, there the equation has been given directly. So but here with the data that is given to us, with the help of the data that is given to us, we need to form the differential equation first, form the equation first, and then we need to differentiate it. So now, since the hyperbola chapter is not over yet, but for the time being I will tell you, the rectangle hyperbola is one of these forms. X square minus y square equals to a square, or xy is equals to c square, one of these two. So now differentiating in both the things, here a is the constant, here c is the constant. So otherwise if you take this for example, differentiating, so the rectangular hyperbola which have the coordinate axis as asymptotes, which has the coordinate axis as asymptotes. What is asymptote? The line, the tangent which touches the hyperbola at infinity, which we will discuss it later, is xy is equals to c square. So since it contains only one arbitrary constant for which we need to differentiate it once, so differentiating with respect to x, we get x dy uv x dy by dx plus y is equals to c square derivative is 0. So therefore this is the required differential equation. The next question is the family of the ellipse whose center at the origin and axis as coordinate axis. So this is the family of ellipse whose center, that means this is the ellipse, all this family of ellipse whose center is at the origin and having axis as major axis is x-axis, minor axis is y-axis is x square by a square plus y square by b square equals to 1. So here a comma b are the two arbitrary constants for which we need to differentiate it twice. Differentiating with respect to x, we get, so x square derivative is 2x by a square plus 1 by b square constant into y square derivative is 2y. Y treat it as x. X square derivative is 2x. So 2y into y with respect to x, dy by dx equals to 0. So if you take 2 as a common and if you transpose that side, so 0 by 2 is 0. Directly we are eliminating like this. So this is x by a square plus 1 by b square dy by dx is equals to 0. So from this dy by dx is equals to minus x by a square if you transpose this onto another side. Therefore dy by dx 1 by x dy by dx, dy by dx by x or 1 by x dy by dx is equals to minus b square by a square minus this is dy by dx into this x if you transpose onto this side 1 by x. This 1 by b square if you transpose to that side, this is minus b square by a square. For the sake of convenience, y by x into this dy by dx can be written as y dash is equals to minus b square by a square, because first order derivative dy by dx can be written as y1 or y dash or d1 likewise. So I'll take it as y dash here for the sake of convenience. That's it. Again differentiating for the second time we are doing now. So here y1 y dash by x this is u by v dash is equals to vu dash minus uv dash by v square. This we know. So likewise this is x square into x into y dash dash minus y dash into d by dx of x1 is equals to this minus b square by a square is a constant. So the derivative of that is 0. Now x into this has become uv, the product of two functions, uv dash. So far we have applied u by v, treated y dash, this u to be y dash and v to be x. Then it has become vu dash, x into u dash is y dash whole dash minus u is y dash u is y dash into v dash d by dx of x. V is x here. D by dx of x is 1. Now this is equals to x into this is uv dash u. What is uv dash? uv whole dash uv dash plus vu dash. So this is y into y dash derivative is y double dash. Y dash is dy by dx. Dy by dx derivative is d square y by dx square. So u into u remains same. Y dash derivative is y double dash plus y dash. This is v into u dash. Y dash into y derivative is dy by dx can be written as y dash. Y into y dash derivative is y double dash. Y dash into y derivative is y dash minus y dash by x square is equals to 0. 0 into x square is 0. So this is equals to x. So in the whole equation, xy, what is y double dash? D square y by dx square plus y dash into y dash square. What is y dash? dy by dx whole square x into. So x into dy by dx whole square minus y into what is y dash? dy by dx is equals to 0 is the required differential equation. Form the differential equation of the family of curves where parameters are given in brackets. The question is same now. So this is the third Roman first question, first bit. So here A, B are the parameters to be eliminated for. Therefore, there are two parameters are there for which we need to differentiate it twice. Differentiating y with respect to x once. Then y with respect to x is dy by dx is equals to a into e power 3x. 3x is x for example. Then e power x derivative is e power x. E power 3x derivative is e power 3x into d by dx of 3x is 3. This plus this is 4b e power 4x in a similar way. So this can be written as 3a e power 3x plus 3b e power 4x 3b e power 4x plus b e power 4x. So 4b e power 4x can be split as 3b plus b, 4b e power 4x. Now, this is equals to 3 into a e power 3x plus b e power 4x plus b e power 4x. This is equals to 3 into what is a e power 3x plus b e power 4x? This is y. So 3y plus b e power 4x. Therefore, this is dy by dx equals to. Now, from this, what is dy by what is b e power 4x? dy by dx minus 3y is equals to b e power 4x. Now again differentiating with respect to x on both sides. This is equals to dy by dx derivative is d square y by dx square. 3 into y derivative is dy by dx. Differentiating y with respect to x is dy by dx plus b e power 4x derivative is 4. This can be written as 3 dy by dx plus 4. What is b e power 4x. What is b e power 4x? dy by dx minus 3y. So I will replace d b e power 4x is to be replaced as dy by dx minus 3y. So dy by dx minus 3y. This is equals to 3 dy by dx plus 4 dy by dx minus 4 3s are 12y is equals to d square y by dx square. Therefore, the required differential equation is d square y by dx square 3 plus 4 7 dy by dx. If you transpose minus 7 dy by dx minus 12y, if you transpose here plus 12y equals to 0. This is the required differential equation. So, but this is a little bit tedious process, right? So, let us find an alternative for this process. So, as usual, y is equals to a e power 3x plus b e power 4x. Aliter. So, differentiating once, y1 equals to 3a e power 3x plus 4b e power 4x. Again differentiating, y2 equals to y derivative is y dy by dx. We can also write it as y1. So y1 is dy by dx. The derivative of dy by dx is d square by dx square, can be written as y2. This is 3 3s are 9a e power 3x plus 4 4s are 16b e power 4x. So now this can be eliminated through the process of a determinant. So here this can be written as a e power 3x plus b e power 4x minus y equals to 0. This is 3a e power 3x plus 4b e power 4x minus y1 equals to 0, and this is 9a e power 3x plus 16b e power 4x minus y2 equals to 0. Now this can be the parameters a and b can be eliminated through the process of determinants as well. So here the determinants is a e power 3x, b e power 4x. Coefficient is a e power 3x and b e power 4x coefficient is 1 and b e power 4x coefficient is 1. So minus y. Here a e power 3x coefficient is 3. So b e power 4x coefficient is 4 minus y1. And here 9, 16 minus y2. This is equals to 0. If you solve this, we can get the differential equation. So this is equals to 1 into 4 into minus y2 minus 4y2 minus 16 into minus y1 minus 16 minus of minus plus 16 y1 minus y1 into 3 into minus y2 minus 3y2 minus of minus plus 9y1 plus into minus minus y into 3 16 is 48 minus 9 4s are 36 equals to 0. Now this is minus 4y2 into 1 minus 4y2 minus of minus plus minus 4y2 plus 3y2 minus y2 minus 4y2 plus 3y2 minus y2. Next plus 16y1 minus 9y1 is plus 7y1. Next here 48 minus 36 plus 12 into minus y minus 12y equals to 0. This can be written as, if you take minus in common, y2 minus 7y1 plus 12y equals to 0. So if you write back y2 to be d square y by dx square and y1 to be dy by dx, then we get d square y by dx square minus 7 dy by dx plus 12y equals to 0. This can be compared with this d square y by dx square minus 7 dy by dx plus 12y equals to 0. So one of the two methods you can adopt to solve or to eliminate the arbitrary or parameters.